So next up, I'd like to introduce Dr. Phong Nguyen from FPT Software. He's actually the Chief AI Officer of FPT. It's a global company, and he has a very eclectic background. He was previously a long-term tenure at Hitachi Labs, and I believe he knows Dr. Chetan Gupta from those days. And more interestingly, he's been actually collaborating through that affiliation and with the Mila AI Institute, which is Yoshua Bengio's lab in Montreal. And he's been doing a lot of work in learning, I think, in next generation of learning and learning research. Very, very interesting background. He was educated at Carnegie Mellon and then got his PhD at Tokyo University. Dr. Nguyen.
Thank you so much. Thank you very much, everyone, for having me here. Very honored to be here and give a talk to share with everyone about my work in FPT. So just like in the very kind introduction. So I used to be with Hitachi for almost 10 years, and then before I moved to FPT, a global company in IT services. And we about 30,000 employees with almost $1 billion in revenue. And when I go to FPT, I have to start everything from scratch. They created the title Chief AI Officer just for me, and I'm very honored to have that. So our R&D lab was built from scratch in this year, and up to now we have 42 submissions in this year, with 15 accepted publications into the first tier conferences, including ICML and Europe's. And my job is not stop at R&D, but extend to also into business solution unit. And through the connections, I connected with Landing AI, and another company in Silicon Valley focusing on visual inspection. So this publication was back in my day doing research with Chetan. So he mostly know all of this research. So well, today I would like to talk about my work in FPT. We focus, like I mentioned, we have a business solution unit. So we are pretty much doing a lot of practical AI application. And when I mentioned about my focus is about data-centric AI for practical application, well, so many people actually thought that data-centric does that mean that you focus on collecting a lot of data and to build your AI? Well, it's actually not. It's not about the quantity of the data. Data-centric is about the quality of the data. And it's very different from back in the day I doing my research, where you have a curated data set. And in academic, we compete on the model-centric, right? Because an AI system is combined with data and code, so you fix your data and you try to improve your model, your code. That is in academic. But then move to applications, like many other talks today have mentioned. We face a lot the challenge with limited data. So data-centric focusing on solving the problem in industrial with curated and focus on the quality of data instead of the quantity of data. And I upgrade this a bit more based to the end-use notion of data-centric. We cannot curate a good data set without human knowledge. So I will explain a little bit more in my example a bit later why human knowledge should be a very important force into this picture. So when we do practical application for AI projects, so we often face with three of the challenge: not enough data. The stakeholders want to have the best performance possible. Like, you want your AI to do good things. And finally, explainable means that in some of the project, explainability is a must. Because it's based on regulations, it's based on the requirement. Human cannot trust AI if they cannot understand about it. So in order to solve these three challenges, we apply the most recent framework. It's called MLOps. And our MLOps handle data, model, deployment, monitor the results in a unique system with human knowledge, sharing and accelerating. So we not only combine an ultimate, we are not only have an automated system like many others are pitching, but we believe monitoring the results with the human knowledge is very important factor. So over here, you can see the different stage, acquiring the data, organize and analyze the data, and deliver with the feedback loop. So how human knowledge in AI can be applied? So this is a pipeline. So human knowledge improve each step of the AI pipeline in order to overcome the three biggest challenges I have just mentioned. So in the data, human needs to know what kind of data need to be collected. And most of the data, most of the problems in the industrial settings is involved with feature engineering. Nowadays, we do not have end-to-end system for most of the data that we acquire so far. So aside from image data, right, we have tabular data, we have slot data, we have system data, which and we have, for example, like IoT, time series, and sound data, which requires a lot on feature engineering. That's a lot of human knowledge to extract those features. And when doing the AI model, we consider the trade-off between precision and recall. That's another know-how over there. And finally, when it comes to deployment, expert validation is a must. So great mind thinks alike, I think so. So that's why when I discussed with Dr. Christopher, we found that, yeah, we actually had a lot in common when he showed us the I framework, enabling, integrating, and assembling. There's a lot of human in the loop, exactly the same thing, but it's much nicely clustered and in a very systematic way, from enabling, integrating to assembling the motor. You can see over here, human in the loop, also from the data curations to data featuring into the also in the assembling when the motor is deployed. So at the end of the day, make high quality data set with human knowledge is the goal of the human center and data-centric model. So we create high quality data by three different techniques. We use data generation, data augmentation, and of course human knowledge. So I will give example of how human knowledge can play a significant role in terms of model improvement. And this is a real story. So in our company, and there are many other companies out there who have nowadays in the scale of thousands of employees, I mean even like a couple of tens of thousands. Some companies have hundreds of thousands company. So understanding and ensuring your employee happiness nowadays is very critical since the talents pool are very limited and the turnover is always a problem, a big problem for companies where the talents will leave the company if they're not happy. because there's so many choices, right? So one of the practical solutions that I built for FPT was trying to understand the employee happiness and to build a model to predict whether in the next 1 to 3 months, who is going to leave the company. So if you think about it, if we just rely on the existing features, like the raw features we collected from the operation of the data, we cannot achieve a very good results in terms of prediction, because human we are, as an employee, you always try to hide all the fact that you are going to leave the organization, right? So as much as possible. So if you put just the data science team into this problem and work alone, they probably will just put the bunch of features, a bunch of data together and try to build a model on top of it. But we found that the performance is very, very low. So when I discovered the problem of isolated ideas from domain expert, here it means that the HR people, the people who have HR skills and was trained to understand the employee, we were be able to combine with a lot of features generated from the domain expert. For example, we have a lot of freshers who join the company when they graduate, or we have a lot of rehired employees, those who left the company and come back. Those special groups are actually behave very different from other groups. And then we found the behavior also very different from people who live far away from the company. And before the pandemic, they have to travel to the company. And even after the pandemic, nowadays, things are getting back to normal. So those who are living far away also behaving very different from those who are living closer. And then some of the, because due to the nature of the project, our employee needs to go from project to project. So those who are in the middle of projects, the effect, the behavior also very different. And also, of course, the review of the direct manager impacts a lot on the decision of the employee to stay or to leave. So only HR people can have these domain knowledge to combine into the features of the data set. So from the raw existing features, we were able to extract all of those new features, we call hidden features, because it's not revealed in the raw data set. But those have to be curated and reviewed, and we do it in an agile way. Review and feedback, and then testing, and can come back review and testing again, in order to improve the performance. So here again, I would like to highlight the combination of machines and human are super important. Aside from those features created by the expert in the HR field, we actually have a human review at the end of the month. People who have specialized skill in predicting whether the employee is going to leave or not. And we actually combine the prediction of the machine and the prediction of the human together in order to detect who is going to leave, so that we can have an early mitigation action. For example, like have a talk with the employee, find out what he's feeling, or raise the package if the package is under the norm, and so on. So we will combine these together, re-ranking in a heuristic way, and with the final results, we can accurately identify even further the employee who is going to leave. So combine the machine prediction and human predictions is one of the key results to lead to better motor. Finally, explanation is very important in order to make actions, right? So over here, we have the prediction score by AI, and we also have BUL, which is business unit leader, who was a leader, that confirm of these factors. And these turn reasons is extracted from the motor itself by weighting the important factor and using some of the explainability methods. We have like Shapley or other methods in order to understand the change reason. And sometimes there's some conflict or some disagree between these evaluation, and we have to make a decision based on one of those. And at that time, we still trust the human instinct compared to the machine. So to conclude my sharing today, I have a few key takeaways. I am coming from academic. Now I'm making a lot of practical AI applications. So I found that human knowledge is critical to overcome the three major challenges in applying AI into real applications. So in our case, the case of applying AI in human resource function, we found that human knowledge creates high quality features for AI motors. We can combine AI results and project manager survey to re-ranking the results and achieve the very high motor performance. So machine makes some type of mistake that human doesn't make, and human makes some type of mistake that machine doesn't make. So when you multiply these two arrows, you will have a smaller arrow. That's basic science. And finally, managers finally validate AI results and explanation in order to take appropriate actions, and it's go into the loop and make the AI motors better and better over time. So thank you very much for your attention, and I hope you enjoy the talk. Thank you.
Question?
Oh, come on, Shaitan.
Okay, I'm going to ask you a hard question because I know you can answer that. One of the things about deep learning has been that you don't need to do feature writing by yourself, right? It automatically does feature generation. So how does that sort of tally with what you're saying in terms of feature generation using human knowledge?
So how much what?
So in some sense, isn't deep learning doing something similar to experts here by generating the features? I'm playing the devil's advocate here.
Yeah.
So
the problem of deep learning is there's a few problems with it, right? The first thing is at the moment there's not much of deep learning that's built for tabular data. That's one of the key things, and most major of the data nowadays are in the form of structured data. That's what we have been collected and accumulated over years and years. And the second problem of deep learning is explainability. I used to work in project with Hitachi with tabular data and with deep learning trying to explain for tabular data, but it's still very far away from a very traditional and tree-based motor, for example. The performance is still much lower, and the explainability is much lower as well. So there's still a far and a long way that we can apply raw deep learning into the current data set.
thank you, that's a great answer.
Yeah. Thank you.
Thank you very much. I'm interested in implementing the human knowledge efficiently. So is there any idea or techniques to consult or?
Thank you. So to implement human knowledge effectively, so I think it's first come from the human, how to manage and how to put things together. So today I learned a lot of things. Like I learned from the demonstration this morning about how we extract human knowledge in a systematic way with just natural language. And in our case, we focus the human knowledge in feature engineering because, like I just mentioned earlier, except from image, we can do end-to-end learning. Many other type of data, it relies a lot. I would say the impact relies a lot on feature engineering. So I think focusing human knowledge in feature engineering is one of the efficient way to build the good motor, rather than focus on the building a good motor. Because nowadays, the good motors are already available, and it was open source, a lot of that. So, but the feature engineering, you are going to win over your competition just because of that. I don't see a lot of companies who win because they have a better motor.
So you talked a little bit about the value of the human in the feature engineering, but in the talk within the MLOps framework, you also said there's value of the human in the monitoring step. And I'm curious if you have any success stories that you can share in that step, because I think that is kind of a little overlooked factor in all of this, and how you take the output of that monitoring and then feed it back in.
It's great questions, actually. I didn't mention it explicitly in my talk, but actually here, if you see this slide, actually that's a review part by human. So after all the engineering I mentioned over here, when the predictions came out from the motor, we combine these predictions with human review. So monitoring and reviewing is part of the human knowledge in the system. And we found that there's overlap between machine and human, which is the confident case. Those cases are definitely will leave the company. But there are some cases that human can predict, but machine cannot. And there are some cases that machine can predict, but human cannot. So if we combine all the total together, we actually reduce the false alarm and increase the precision as well. So that's how we actually monitor the results. And in order to create all of those features, in order to improve the performance of the motor, we do a lot of review and feedback all the time in order to pick what is the right feature, what is the feature that makes sense. And these are very agile and very intensive in the loop of improving the motor. So we do have a very important factors in the reviewing and monitoring. Thank you.
I think we'll have to keep time.
Thank you.
We'll have one more question, and then we'll have to move on.
You mentioned about the feature that generated from the model and then from the human. So have you doing any analysis about number of feature from the model or from the data and number of feature from the human, and how is this interfering between these two?
So we do a lot of we do a lot of feature generation by the machine. For example, you combine two random columns into one column. That is one kind of machine generated features, and you have curated features based on human experience like this. So we don't have a scientific way to compare which one is more effective at the moment. We didn't do that evaluation systematically, but we just when I lead this project, I just have the feeling that the features generated by human is the weight, the impact to the motor is way better than some random generation of the machine. However, that is particularly in tabular and in this kind of data. But in other problems, for example, like image classification, we do a lot of synthetic data generation. For example, you turn the pictures, you generate new pictures based on the current pictures you have, and you put it in the model and training. it actually helps a lot too. So I would say it's different case by case.
Okay, thank you, Dr. Nguyen.
Thank you for your attention.